Bismillahirrahmanirrahim. Assalamu alaikum and hello everyone. This is Hamayu. In today's video, we will be discussing the vector autoregression model, how it works, and most importantly, how we can, estimate it while using the R Studio. So in the first section of this video, we will be, covering a very brief overview of how VR works and what it is. And in the second part, we will be actually modeling it through the R Studio. So let's move on. So what is VAR and how it works? That's an important question. It's like AR model. You must have seen the autoregressive models. You must have seen the ARIMA model as well, in which we have got AR and moving average both combined. AR is actually regressing lags of certain variable on its, present value. For example, if you talk about the sales of cars, take the previous year sales and regress the previous year sales on this year's sales. So that is actually AR1 model. So VAR is exactly like AR model, but it's actually, considering not only one variable and its lag value, but rather multiple variables. So for example, let me give you an example. We have 4 variables: employment, unemployment, labor productivity, and real wage. So how can we, mathematically present, the VR model if we have got these 4 variables, including employment, unemployment, labor productivity, and real wage? So if you look at these 4 equations, we will be getting these 4 equations. The first one is about employment. So if you see here, we have got the lag value of the employment. So the previous year employment, and the previous year productivity, labor productivity, and the previous year real wage, and the previous year unemployment. And in the second equation, so we have got the previous year productivity, previous year employment, previous year real wage, previous year unemployment, the lags of one lag of each of the variable, including this own productivity. Same is the case with this real wage, and same is the case with this unemployment, right? So we have got actually a sort of vector of these variables. So in our dependent side, we have got 4 variables. So it will become a sort of vector. So I did not, bring, the matrix form of them, but it will become a sort of matrix. We have got 4 variables on one side of a matrix. We have got the coefficients in between them, and we have got the error terms, in a separate sort of matrix. So it becomes a sort of vector of, dependent variables. So this is what we call, the vector autoregression modeling. So in the vector autoregression, there are certain assumptions or requirements that model it. Your variables must be stationary. That is something very important. If your variables are not stationary, you cannot do this. Second, you need to select the optimal lag length. In the previous example, in my equation, if you see, I've selected only one lags of each of the variables. But in order to select the lag length, you need to check through different tests we will be covering in the R Studio as well. So you need to go through all those tests first and need to consider that for certain equation, how many lags you need to include in the model, right? So that's important. So that was all about, the requirements and optimal lag length, a very great details of how VR works, because, I'll be focusing on the modeling part, which is the second part of the R Studio. So you can read in different, forms, websites, books, etc. So before wasting more time, let's move to the R Studio. Okay. So now I'm here with the R Studio. So first of all, if I show you the data, I've saved this data in a name of data. So let's view it. Okay. So let's drag it down a bit. So I've got 4 variables, the same variables that I show you in the, in the equations. We have got employment. E is actually representing the employment. Productivity, the labor productivity, this is real wage, and this is the unemployment rate. So we have got these 4 variables. First and foremost, what sort of, packages you will be needing for modeling VR model? The very first package that you will be needing is the VARs package. So let me library it for you. This is the package actually. So you need this VARs package. You need T-series package as well. I'll be showing you where do we need them. Series, right, 3. Third, you will be needing forecasting. Sorry, not forecasting, but rather forecast. This is forecast package. I think that's enough. You need these 4. You need 3 packages: VARs, T-series, and forecast. So what is the first thing that we'll be doing here? The very first thing is to declare this data as a time series data. That's important. So how can you do that? How can you declare this data into a time series? Let's declare all of the variable one by one first. So if you want to declare this employment variable, let's name it as employment, right? So I've got this employment. Employment is equal to, I'll be using TS function, right? So TS is actually in the T series package. TS, which variable I want to change. If I see data $E, that's employment, right? Next, what I'll be giving start is equal to C of 1, 1. Let me explain it. Why I'm using is this C of 1, 1. If you see in this data set, there is no years shown in this data. It's not saying which this observation belong to which year. So the years are not actually specifically mentioned. We have got only 1, 2, 3, but I know this is actually quarter data. So what I'll be telling it, consider the first observation and the first, row. So it will consider, this is actually the first year and the first quarter. So how, if I give the frequency to it, if I give the frequency as 4, it will automatically consider it as, the 4 observations per year. So it will become frequency. So it will become in a quarterly data, right? If it is a semi-annual data, then our frequency would have 2 here. So I know that it's a quarterly data. So frequency would be, 4. So that is the first variable. I'm considering it as a time series variable, right? Brilliant. Working perfect. So now moving towards the second variable, that is productivity. Let me name it as productivity. Lengthy name, but it works, right? Again, TS can extract from the data, start equal to C of 1, 1, and frequency again. What is the third variable? The third variable is wage rate. Real wage, it's not wage rate. Sorry, take it from here as well. $RW. Here I'll be using U to extract it from the data, and here I'll be naming it as unemployment. Okay, so this is unemployment. Boom. So now I have all of them, in a sort of proper T-series form, in the, time series data form. So let's, what is the second step? The second step is actually to check the stationarity of all these 4 variables, that whether they are stationary or not. So one way is to check the plots of them, the time series plot, which will tell you that whether they are stationary or not. And the second way, which is, always required, that is actually the augmented decay follow test. So first let's check the plotting of it. So for that, there is a function autoplot, which is present, in the forecast package. Initially, I told you need to have this forecast package as well. So autoplot, see what do we have in the employment. If you see, it's not stationary. There is a clear trend in it. So it's moving upward. It's not stationary. So now see the second one, which is productivity. Boom. Again, it's not stationary. There is a trend in it again. So the third one is real wage. Okay. Real wage is also not stationary. Obviously, there is a trend in it. The fourth one is what? Fourth one is actually unemployment. Boom. It seems stationary because there is no regular trend in it, but that is actually the problem with the plots. Plots can never tell you exactly that whether there is stationary data or not. That's why we always need the augmented decay follow test, which is important. So for that, we'll be using this ADF.test, which is actually present in this T-series package. So ADF.test, I'll be using this employment first. C. So the alternative hypothesis is actually stationary, and the Null hypothesis is non-stationary. So if you see the p-value is greater than 0, so we cannot reject this null hypothesis, which is saying that the data is non-stationary. So let's see the ADF test for the second one, which is productivity. Again, it is right. It's bigger than 0.05, 5% significance level. It's 0.2. Not that big as 0.5, which was too high, but here again is 0.218. So we cannot reject the null hypothesis, which says that the data is non-stationary. So it's clearly non-stationary, right? So the third variable, what was unemployment? So see, it's 0.33. All of them are actually, non-stationary. All of them are actually non-stationary. I did not check the real wage. Again, it's 0.553 non-stationary. Okay. So in order to make them stationary, what we can do? That's an interesting question. So for that, we will be taking the first difference. If it is again non-stationary, we will take the second difference. If it is again non-stationary, we will take the third difference. So how can we take the differences of, the variables in our studio? That is quite easy. So first of all, let me consider the first variable, which is employment, as dip employment. The first difference of employment, diff employment, DIF EMP. For that, we'll be using this diff function. Let's take the, the sort of difference of employment. Okay, I've taken the difference. So let's now plot this diff employment, that how it looks, whether it looks, sort of stationary or not. See, it seems quite stationary now. So there is no regular trend in it, upward or downward. So it seems stationary, right? So second variable was productivity. So let's name it as diff productivity. Diff product is equal to diff of productivity, right? So now let's plot it. Auto plot. Boom. So it seems quite stationary now, right? So the real wage, diff RW, real wage. I'm naming it as real wage. So diff of real wage. Okay, now plot it. Now plot this real wage. Auto plot. Diff RW. Seems quite stationary for me. In the beginning, there is a sort of, bigger number, but let's consider it as stationary. If it is not stationary, you can once again use the augmented decay Fuller test on it, and you will take the second difference of it. It was obviously unemployment. So let's take this diff UNEMP is equal to, take the difference of unemployment, right? So let's plot this one now. UNEMP. See, so it's sort of, so we've got all these variables now sort of in a proper stationary form. We have taken them in a proper stationary form. So what else do we need? That's an important question. What else do we need? Next, as I told you, we will be looking for the appropriate leg length. So how can we select this leg length? How many legs do I need, to properly, work on it? So for that, there is, okay, so if for the optimal leg length, you will need to give the entire data set to a function, that is VAR select. This is the function VAR select. Remember, it needs, the data set, not individual variable. For the data set, we need to, provide the entire data set. So if you see, I've taken already, the difference, the first difference of them to make it stationary. So let's combine all these 4 variables into a single data set. So for that, for example, if I call this data set as VAR data, which I'm working on, so data.frame, give the name of all the variable, which is diff emp, comma, activity. The third one was diff rw, UNMP unemployment. Right. So these four variables now combine into a single data set which I've named as VAR data. Boom. See. So now we'll be using this VAR select. First of all, let's see this VAR data first. So what do I have in this VAR data? So I've got, the four variables, but their first difference to make it stationary, right? So now I'll be using this var select function. Var select, you have to give the name of the data. So what is the name of the data which is stationary? That is var data, right? Okay, so what do I have? You have to check this, the first thing, which is, the AIC HQSC FPE. It says that I'll be needing only one lag in this model for every single, so I'll be needing only one lag. They may provide different lags. For example, maybe AIC gave you 2 lags appropriate for this model, HQ provide 3. Then you need to, select the maximum number, which is actually shown in these 4 tests. But AIC is probably, most useful methodology. So always go for this 1 lag. So if I have penned down that I'll be needing only 1 lag, which is actually shown by all the possible criteria for lag length, now that's quite easy to run this VAR model. So for that, what I'll be needing okay. As you know, I have saved this data, in the VAR data format, and I know, I'll be needing 1 lag for each equation, which I found out the var select function, and now I can estimate the model of var. So if I name it as model, I'm just giving it a name, right? So model is equal to, I'll be using this var function, VAR capital, right? So what I'll be needing to include in this, I'll be definitely needing the data, which is actually the combination of the first differences of all the variables to make it stationary. I've named it as var data, right? And the second argument, that is P, as I already know how many lags I'll be needing in it. So I'll be needing only 1 lag. So I'll put P is equal to 1. Boom. Now let's check the summary of model. So if I check the summary of this model, what do I have? Let me interpret them. So, I've got 4 endogenous variables. So I'll be having 4 equation. And for all of them, I'll be having, the independent variable. So the first variable is actually the employment, which is actually the difference of employment. To make it stationary, I've named it as difference of employment. So it has considered this is the first lag of employment, which is actually significant with the 1% of significance level. So the p-value is actually less than 0.01. The lag of productivity is also significant with the 5% of significance level. All the rest of the variables are actually insignificant. The lags of the other 3 variables are insignificant, right? So what else do I be needing? So this is the adjusted R square value, which is 0.5639. Okay, the second, what else do I have? The second is actually productivity. So for the productivity, 3 variables are significant with the 10% of significance level, and which is actually 5% of significance level. And the 1 variable, which is lag of the difference of employment, is actually significant with the 10% of significance level. So 1 star to the 3 and dot to the 4th. Right, so the third equation is the difference of real wage. For the real wage, we have got 3 lags of the 3 different variables are actually significant. See, its own lag is actually that's significant, quite significant. The unemployment lag is actually insignificant, and the employment lag is also insignificant for the real wage. Okay. And this is unemployment. For the unemployment, the lag of the employment is significant. For the lag of the productivity is significant. The lag of the real wage is actually significant with the 10% significance level. And the constant, which is intercept, is actually significant as well. So that was all about the VR model, how you can estimate it through the R Studio. I gave, a brief sort of overview as well. So I hope it was helpful. Thank you for watching this channel. Please do subscribe if you haven't subscribed it yet. I'll be coming up with more important videos. God bless you all. Allah Hafiz.